The time series NDVI reconstruction in the pre-processing tab is based on the algorithm proposed by Chen. Considering that noises appearing in NDVI mainly occurs in the way of decreasing the value because of clouds or cirrus, this algorithm corrects the pixels with low or empty value by applying Savitzky and Golay filter iteratively. So what we have to do for using this function is to put time series NDVI and set parameters for the subgore filters. We can get more information about the parameters by looking into the paper, but to put it simply, there is a long-term filter which is applied for one time initially and a short-term filter which is applied iteratively until it finds the best fitting value. Since the application of this algorithm tends to increase the value, we can set the upper boundary of the increment by setting the max value. If we leave it as an empty box, it won't set a boundary. In order to check if the parameters are valid, all we have to do is just selecting a layer and click the check button. Then the selected layer will be displayed in the window. Left click on any pixel will display the original values as a green line and dots and reconstructed value as a blue line, so we can decide which parameters to use. Since there are too much shifts in spring and autumn season, I'll modify the parameters in the way of increasing the long-term polynomial and decreasing short-term kernel size in this case. Finally, if we set the output and click the Run button, DRYAD will apply parallel processing by using all of our CPUs to speed up reconstructing the entire pixels. Once we look into the result and compare it with the original raster, we can find the NDVI values are reconstructed.